Good morning, good afternoon, everybody, and welcome to another of our webinars on private networking, private LTE. My name is Ian Gillett from IGR, and today we have 4 guest panelists to talk about applications and services within private LTE, 5G, edge compute, and of course CBRS. These webinars are brought to you by the 2030 Project, who's been producing them. We've got 2 more in the series to come in the next, one in 2 weeks and 1 2 weeks after that. And we're going to get into a few more details on the landscape then. But today it's all about applications and services, which we do get a lot of questions about. Before I get into that, I need to go through the housekeeping, bit of logistics. I'll introduce the speakers, then we'll get into the content. So first thing is we are being recorded today, and the recording will be available in a day or so on the website. You'll get a link with the details. We'll also make the slides available today as well, so no need to try and write everything down. We will be taking questions. If you look on the GoToWebinar control panel there, you'll see there is a questions tab. Feel free to type away. As we go through today, we will work the questions in. We'll also have time at the end as well. As I said, we will have future events as well. I'll have a link in a second to the webpage with those details. So with that, let me quickly review the speakers today. As I said, my name is Ian Gillett, down in Austin, Texas. Ken Hosak is VP of IoT Strategy and BizDev for Cradlepoint. He's in, I think he's in the Bay Area. He'll tell you where he is in a minute. Kevin Hansen is BizDev from Google Wireless Services. He's definitely in the Bay Area. Mr. Jim Jacobellis, I know he's in Arizona. He's VP of Solutions and Business Partners for Geoverse. And then Gary Wood is VP of Intelligent Edge for Pivot Technology Services, and Gary is up in Omaha. So we're kind of all spread around here, but hopefully this all fits together. So what we're going to do is, rather than speak in turn, everybody takes 10 minutes, we're going to kind of have a conversation and jump around different subjects. Firstly, I'm going to give a very quick overview of private networks, what we're going to be talking about. Then we're going to get into what are the current applications you see with private LTE, CBRS type applications. I mean, this is a very early industry. There are some good examples out there, but really we'll talk about the capabilities, what's been deployed, what you can do today. Then we'll get into kind of the next generation of more advanced applications. What are the things that we've got coming down the pipe that we expect to be doing? And then we're going to wrap up with a couple of slides on 5G capabilities and applications. 5G does give us some things that are increase the capabilities. And so we wanted to work that in and kind of end that way. We'll wrap it all up, and then, of course, we'll take questions at the end. In terms of resources here, the Private LTE for Enterprise website has got all the content, all the webinars, different videos we've put together. And then, of course, we've got the sites for Cradlepoint, Geoverse, and Pivot. Pivot, notice, is Pivot TT, 2 T's and 1 S. It's pivottechnicalservices.com. And I didn't skip Google. Everybody knows google.com, but what we're going to be talking about today, what Kevin's going to be talking about today, his area is on the Spectrum Database / SaaS area. So that's how you can get to that capability or the details on that without doing a Google search, I guess. So with that, let me just kick things off. I showed this diagram last time. I've used this quite a bit. This is kind of the view of the world as we see it in probably 5 to 10 years, where everything is 5G. You can see we've got 5G macro cells on either end. These yellow areas are the small, more densely populated areas of capacity for 5G. What we're really talking about with private networking is that you can really put in your own private network. It could be for a manufacturing plant, for example, in a stadium, obviously in the commercial space here, we've got also shown the healthcare. But what I want to point out today is the text I don't normally go through a lot, is all the applications enabled here. So within a manufacturing facility, actually with any building, we always start with smart building and utilities. This is taking on new meaning these days with COVID-19. So, the ability to enter the building, be tracked, counted in the building, counted out the building for social distancing, those types of things. Security is a big one. Big use of private networking, so the ability to deploy cameras, keep all the security footage within the building with an edge compute solution. And so a lot of different things. Robot control is another one that's popular. Discussion point. Data analysis. There's some drones flying around here. So there's a wide variety of applications we can talk about now. And what we're going to do today is get into that and really talk about those different aspects in terms of what's available today and what we can actually, enable and what will be the future. So that's kind of the context of the whole thing. So the first thing is I'm going to ask each of the speakers today. I'm going to start with Gary from Pivot, just to introduce basically 60 seconds. Who are you guys and what do you do? Gary?
So thanks, Ian. Pivot is a VAR, an SI, a managed services company. We're about a $1.2 billion company revenue-wise. We are a workforce of roughly 1,000 people. We have a network of field resources, field engineers we can tap into for deployment services of roughly 8,000. We have an ecosystem of over 800 suppliers. We ship about 4 million units a year, and of those, we do about 27,000 solution integrations or more custom integrations of technology a year as well. So we have all these personalities, and the way we bring that into the private LTE space is we take technology from all the players in the value chain and in the reference architecture and in the private LTE ecosystem, and based on customers' choice of radio type, server type, overall architectural choices they make, we bring together all those technologies and create a holistic solution that is deployable, and then we provide the services to actually deploy and activate that network, as well as to support it from a day two support standpoint and onward, and then monitor it, security monitoring, network monitoring. So we kind of bring the full complement of services for enabling the complete life cycle of a private LTE network deployment. And in addition to those things, lastly, we do have this very unique position as the exclusive channel for a multi-access edge compute or MEC software element that sits at the heart of that network and is the basis for managing the very secure connectivity to applications that we'll be talking about today.
Okay, great. And yeah, as you said, we're going to get into the edge stuff. We've already had one of our first questions. This audience is not going to be shy, so we'll work that one in as we go forward. Okay, so Kevin, I'm going to hand to you. I don't think you need to tell people who Google is and what they do, but maybe just talk about what you do within CBRS private networking and what your role is.
Yeah, thanks, Ian. So I think as it pertains to private LTE and CBRS, it's actually a really strategic space for Google. It's something that's really important to us. Just at a high level, almost all of our businesses depend on a healthy internet, whether that's on the consumer side, so everything from Chrome to Google Photos to Gmail, or on the enterprise side with ads and Google Cloud. We need a healthy internet. And so the more private networks that are out there, the more people that are out there providing connectivity, the better. And also, we just have goals of creating an abundance of bandwidth. And we think that private networks really have the ability to create a lot of, or really fill gaps that haven't been delivered. And so that could be in congested areas or in building connectivity where it's been tough to get, typical coverage from carriers, or even out in rural areas as well. And so Google's all in on private LTE and all in on CBRS, and we're excited to see what the space brings.
Okay, great. Thank you. And I like this slide. You've got to spread all the logos in, I think you guys use, right? Minimal words, lots of pictures.
So. Always find more.
Okay, so Ken, I'll pass to you at Cradlepoint. Who are you guys? What do you guys do?
Yeah, thanks, Ian. So Cradlepoint is the worldwide leader in solutions that enable enterprises to use LTE, cellular, as an enterprise WAN, as an internet connection. And so our business is really split into three areas. We go after these fixed locations, and these can be retail stores or branch offices that are using LTE and soon to be 5G as either a primary connection or as possibly a failover connection. The second segment is vehicles, mobile locations, and so we're very widely used in the public sector, public safety, city buses, school buses, things like that. And then the third segment is machines, IoT machines, and these are things like kiosks, digital signage, etc. And I love these types of webinars to go through the use cases because I've been with the company almost 11 years, and in my time I've seen some great use cases. And so we're going to talk about today how that applies to private LTE and some of the use cases that carry over to that.
Right. Great, thank you. And then Jim, whoops, there we go. So Jim, I'm going to let this slide build here. There we go. There we go. I didn't realize I had a build on it. So Jim from Geoverse, who are you guys? What do you guys do?
Thanks, Ian, for the intro. Geoverse, little over 2-year-old company, but as you can see, we're part of a larger telecom holding company by the name of ATN International. So we're a cellular carrier, a cable company, a CLEC in locations around the world. And the companies you see there are actually some of our North American assets. So you go to the US Virgin Islands, you go to Bermuda, you go to the Cayman Islands, we're actually the cellular carrier. But more applicable to us is we're combined with that company you see, ComNet and Choice, we're just one company together now. And ComNet is the largest wholesale roaming carrier in the U.S. So for CBRS and private LTE, we're able to bring into the equation reciprocal roaming, other carrier services like VoLTE and E911. And we share that resource with our partners. So it's not just for Geoverse to use, but for partners in the private LTE ecosystem.
Okay, so I do like this slide. I'm glad you highlighted it. I think it's important to realize as we go through this, you are part of an operator as well. So that connectivity piece, as we get into some of the discussions on the application, becomes really important, right?
I think so.
Yep, all right, great. So, Kevin, I'm going to come back to you and talk a little bit more about the capabilities here that you enable within the applications. Some of the things that I think if we're trying to start at the top here and drill down, we've got a lot of CBRS apps we're going to get to in here, but what do you enable in here? What are the capabilities you bring to this to enable those apps?
Yeah, to build a private LTE network, there's a lot of pieces that need to come together, and you can pick and choose from different equipment vendors and handset vendors in order to build the kind of network that you need. And we're bringing really 3 tools into that mix that you can choose from. One of them is a spectrum access system. So anyone out there who is deploying a private LTE system based on CBRS, you need to connect your radios to a spectrum access system. CBRS is shared spectrum, as I know we've spoke about on previous webinars, and so the SAS is going to make sure that you're not interfering with incumbents. One of the unique differentiators with this is that we bring in all of our unique geo assets. So we have down to single centimeter level data, 3D renderings of cities and other highly populated areas in the United States, so that as you are planning out a network, you're going to know what real-time interference looks like. So you can think of a user interface that's very similar to Google Maps, and you can drop cell phone towers and radios, and you can see how signal's going to propagate to make sure that if you're building something like a campus network for your business, that you're actually going to get the coverage that you want. And then finally, we have training programs as well for those who want to be CPIs. So if you want to be an installer of CBSDs, then you need to have this. And so these are the 3 things that we're bringing to the market.
Okay, so on that network planner piece, just so I understand here, if I've got let's say a campus with multiple buildings, I can look at what coverage I have today from the different networks, I may find that the north end of the campus has got pretty good existing coverage, but the south end has got nothing. And so I can tailor my outdoor CBRS to that as well as do the indoor. Is that the way to look at it?
Yeah, absolutely. And it's really interesting too. So if you drop some radios on there and you notice that you don't have coverage, let's say in the north part of your campus, then you can hit a little button that says that's called Path Profile, and it'll actually turn the world on its side and show you from line of sight exactly what's blocking your signal. And so we know the trees, we know the buildings. I think we call it clutter. We have all the clutter information. So we know what's actually in the way, whether it's a freeway or a building or a tree or a shrub. And so you can see where your line of sight is being interrupted. And so this can help you save a lot of money before you deploy, just to make sure that you actually do know how your signal is going to propagate. Indoor, we can give some rough guidance, but right now the tool is more tuned for outdoor.
Okay. I think most people call trees and shrubbery, by the way, they call it landscaping or scenery, not clutter, just to let you know.
Yeah, in the real world, it's landscape and scenery, and in the world of wireless, it's just clutter.
And we did have actually one question here, which I'm going to take. I'm just going to read it. Did you say down to the centimeter level? Is that correct?
Yeah, that's correct. So in most of the United States, and especially in the highly populated, dense areas, not single centimeters. So I think it's in like between 2 to 5 centimeters of accuracy, roughly, for buildings and cities to see how signal's going to propagate.
Okay, and for old school, an inch is what, 2.5 centimeters, right? So, yep.
2.54.
Good. Good. So I'm going to go back to you. Let's talk about these use cases. Let's start, we've talked about capabilities. Let's drill down here. You mentioned in your intro your long history here. So what are the things we do see as, the applications here for private networks?
Yeah, so from a big perspective, kind of a top level perspective, where we're seeing at least our business go from a private LTE standpoint is enterprises that want to cover a large area with their own local private network. And in many cases, they've tried to do this with meshed Wi-Fi and have had mixed results. But, some examples right here of a hospital, and this might be more of an in-building example, but you can compare the hospital with a hotel or an office building. They're all kind of similar. But they may be able to set up a private network inside the hospital, multiple slices. So you might have one for your hospital and staff members, hospital staff members. You might have a second for tracking high value assets. You might have a third for vendors that come in. Outside the hospital, I spoke with an IT director of one of the major hospital providers that is looking at approach routes for ambulances. So as an ambulance comes near the hospital, a lot of times they follow the last, the same mile, and they want to light up the approach route with private LTE so they can pull information in a HIPAA compliant way out of the ambulance and get it to the hospital so the doctors can hit the ground running. On an amusement park, and again, this is an enterprise, but it could represent a stadium or a shipping port. You have this very large area with a lot of operational needs. And this amusement park pretty much carries every cradle point use case. You have retail stores, the fast food restaurants, you have maintenance vehicles, you have security vehicles, you have buses for employees, buses for customers, et cetera. And to be able to set up your own operational network that's in a spectrum that doesn't get Wi-Fi interference is very, very attractive to some of these large operators. And then smart city, we're seeing great opportunities for cities to leverage this for everything from extending their fiber network to places that are difficult to get to. So one city I know has fiber to a fire station, but not to the park that's across the street. And so this lets them use that as a jumping off point to get connectivity to the park. And then we're seeing cities that are looking at connecting their traffic intersections with private LTE to run the traffic light control, et cetera. So it's basically people that need a wide area land. And there's a lot of great applications that these cover.
Okay, so just to be clear, the hospital example, the building example, and then the amusement park, those are things that are deployed today, right?
Yes, but I've had conversations specifically about using private LTE. On a stadium, for example, Wi-Fi is not really good to use as an operational network once all those fans pack the stadium. It's very, very congested. They're using the same thing. So if you're trying to connect your security facilities on game day, or you're trying to look at cameras from NASCAR while they're actually in the cars, Wi-Fi is just not really good on race day for things like that.
Yep. Okay, good. Jim, back to you. So what is it Geoverse brings here? We've talked about the networks. We've talked about the planning point of view. So where does GeoCore, GeoTrade fit? And I like your diagram here, so I'll let you just explain.
Okay. Thanks, Ian. First of all, Ken mentioned a whole bunch of private LTE applications, and I think he was spot on. But if you're not a mobile network operator and you're trying to do some of those applications all by yourself, you're limited as far as what resources are available to you. I'm not going to draw this out, but you need to get codes in order to get LTE to work, and you have to go acquire codes, acquire SIM cards, acquire all this stuff to get it to work. And even when you get all that, you're kind of limited to this bubble where you can have this service. So Geoverse, because we're a mobile network operator with all these carrier type services, we offer to our partner network and others the ability to tap into this GeoCore resource. And the GeoCore, you can think of it, we haven't got into the EPC part, but it's almost like adjunct software to your EBC that allows you to do private public things. It allows you to do, make your CBRS network more like a carrier network, and not only for roaming services, but for emergency services like E911 and CALIA. VoLTE stuff becomes a little bit more seamless, all that. And then the GeoTrade element you see at the bottom is our platform to be able to deliver analytics in a portal way to the enterprise, not only for the radio network, but more for the devices. So one of the big issues that enterprises have had, that they have all these devices going into their building or onto their premise, and they have no visibility into that. So Geoverse with the GeoTrade platform gives you that visibility. That same platform in the future is going to be used for, think of it like an eBay-like trading platform, because remember, we're the man in the middle that connects you to the carrier world, and there's going to be a lot of new carriers, if you will, coming into that. So if you're an enterprise, you're taking advantage of 80 megahertz of spectrum, you only need 40, why not offer that other 40 up for sale? And this GeoTrade platform is going to be, that monetization window for the enterprises.
Right, and just going back to the GeoCore, this EPC platform here you're talking about, I've seen your installation, and if anybody's thinking this takes up half a data center like a very big operator's EPC does, no, this is quite a small installation. It's just a couple of racks, right?
Yeah, it's pretty much software that you can virtualize or put on a COTS server, depending on what you want to do. You can also have it at the edge behind a firewall, and we're also building out city installations of this for smaller enterprises to take advantage of, and people that don't want to have kind of edge stuff. So bringing that low latency experience and all these other services to the edge or to a metro, because if you keep it metro and not way back in the cloud, we found that you're able to get edge-like latency without having to invest in all the edge peripherally and keep track of that. So we're hoping this scales way down, so that imagine, like a small, really small middle prize being able to, have their guest phones work, point of sale work, all that stuff work without having to invest a ton of money in the infrastructure to support it.
Right. Okay. And in case anybody's wondering, I'm going to ask Kevin just to comment on the geospatial side of this, because it's kind of interesting. I haven't forgotten about Gary and Pivot, but he gets to catch up in a few seconds here. So Kevin, everybody knows Google Maps, satellite view, street view. How does it play in here?
Yeah, well, I spoke a little bit about the geodata that we use for our network planning tool. And the geodata really comes into use, that clutter-aware geodata, in two ways. So one is making sure that devices don't interfere with each other, because we have really good information about the clutter, like I mentioned. So we know what will actually be real interference and what won't. And the other is just providing broad coverage. And we've been working with wireless internet service providers to make sure that they have point-to-point communication to homes that they want to deliver service to. We've been working with the major network operators, but there's a huge private LTE use case here as well that we're working with. Ken spoke a little bit about amusement parks, for example. Amusement parks are a great use case for when you might want this geodata. So if you want to know if your amusement park or your theme park or your water park is going to get good cellular coverage, you can map that out really easily with our tool. And the nice thing about CBRS and it being private is that you control that network. So if you go to have a carrier operated or carrier deployed network in your theme park or in your stadium or any sort of campus, anytime you want to make a change, it's going to take a long time. And what we found with theme parks is oftentimes by the time they want to make a change in the wireless infrastructure they have delivered by traditional carriers, they've already changed around their theme park. They've added new rides, they've added new features, and those mess with coverage. So they don't have the ability to be dynamic. So I think that the geodata really has a strong play in private LTE as you build out these new sort of areas and being able to be quick and dynamic and move things around so that coverage is accurate. And we fly our planes over most of the country, a couple times a year. And so the data that you'll find is pretty up to date.
Okay, and as I mentioned, I live in Austin. The downtown area is there's always new buildings going up, multiple buildings.
Yeah.
So the fact, I mean, this is a dynamic resource here you've got, because obviously something can go up. There's new signal, the signal changes, right? There's blockage, et cetera, et cetera. Yep. So, all right, great. So Gary, back to you. The slide here. So let's talk about it from an edge point of view now. And I kind of like the way you've done this as a phase one. What have we got today? Ken talked about it from the cradle point of view, but go into a little more detail here, and especially around the latency side of things.
Sure. So for those people that joined the webinar 2 weeks ago, there was a lot of focus on simply creating and enabling a connected environment with private LTE and what was involved in that and what did that architecture look like and what were the elements of it. And so there was great discussion around that. If you sort of move from that part of the discussion represented on the sort of the right 2/3 or 3/4 of the diagram here to, okay, now that I have that in place, I've created that connected environment. Now, what do I do with it? How do I actually derive value from it in the near term? What can I do immediately in my business to unlock value from the investment that I've made there? It's my assertion, and by the way, you'll hear different perspectives on this call as to what this might look like and what journey customers might take, enterprises might take, and that's good. That's what we're here for, right? There's not one right answer here, and so I'll posit one particular viewpoint and what might be the case for many enterprises. And for me, that would be that if you look over on the left here, that this connected environment actually first is applied to unlocking value with legacy applications. And it's the applications that I have today. So now, if you sort of look at the journey of how you access data and applications over time, companies over the course of the last 8 to 10 years have migrated huge amounts of data and application content from conventional data center environments to the cloud, and that's delivered huge value. But it's also come with trade-offs of latency and cost for access and egress, and some trade-offs relative to security as well. So now we look at what is the next chapter in that book, and really it starts with edge compute. And once you have edge compute as a central component of this type of connected architecture, now I can actually drive applications down to the edge, applications that used to be accessible only via a workstation in a conventional office environment over time migrated to, mobile devices and laptops connected over Wi-Fi. But of course, the trade-off was, Wi-Fi often wasn't reliable. It didn't often have the security characteristics that it needed to have. It did, because it over time got congested with a lot of use. It didn't deliver the kind of latency that you needed for some applications. So now here we are with Private LTE, and I think the real first chapter in the book relative to value delivered by this kind of architecture and creating private enterprise LTE is legacy applications that now can sit at the edge and be accessed securely with very high bandwidth and with very, very low latency. And so it becomes an upgrade to my current application environment that's not nearly as sexy as talking about tomorrow's use cases and lots of wonderful new things, IoT and beyond, but certainly that today, in very pragmatic terms, moving your legacy applications into this kind of environment for very low latency access delivers a lot of value immediately. So that's just one perspective.
Right. So an example, if I'm looking over on the right-hand side here, you've got point of sale there, but also you've got security cameras. So, I mean, security cameras are in buildings already today, right? But you have to run a wire to them, et cetera, et cetera. With a private network, we can put the security cameras where we like. With the edge compute, you can store all the data locally, do the analytics. Point of sale, as Ken mentioned, in a stadium, the Wi-Fi gets overloaded. We could put the point of sale on the private network. So that's the type of thing you're talking about, these existing applications?
Yeah, and I think video is absolutely one of the more compelling use cases enabled or enhanced with Private LTE. I'm going to hit on that a little bit later, but I think clearly some of the use cases emerging there with COVID-19 mitigation, thermal screening, video surveillance, surveillance in a retail environment for both loss prevention, as well as better analytics around what's happening with footfall, traffic patterns, et cetera. Lots of really cool things happening with video. So yeah, it could certainly be argued that video for the companies that are ready to do that, that's also there for the taking. And as you said, Ian, it's the freedom to put cameras wherever they need to be and not just where there are Cat5 runs. So that's
right.
a huge development.
Okay, all right, great. So Jim, I'm going to come back to you and as a build on this one. So again, talking about what's being done now with CBRS, you've got a big list of applications here. You've got a picture of a security camera on top as well. But what I want to focus on this one is some of the more, I'll call them the more mundane, the more traditional, but push to talk, home student broadband and voice over LTE. If you can talk through those a little bit.
Sure, and I was hoping to talk about video analytics, but I won't steal. I won't steal Gary's thunder.
Go for it, Jim.
I think Ken touched on what's the most relevant kind of common denominator in all these applications, and there are a lot of mainly kind of small CBRS deployments out there right now that are going to get bigger over time. But I think the common denominator is, where is Wi-Fi not good enough? When you can look at it from an ROI perspective, mesh Wi-Fi, comparing it to CBRS, there's an immediate ROI benefit with CBRS. Security, voice characteristics of Wi-Fi versus all that. Wi-Fi is not good enough in those areas. The other kind of common denominator for a lot of these is the ROI. If you were to go and put fiber there versus using CBRS, because remember, you get fiber-like performance. So that's why you see a lot of these video analytic, some of these electronic signage use cases. That's the fundamental reason why that's happening. But I think push to talk, is something where land mobile radio, where you had your own little license, was where it was happening before. And now a lot of that is moving over to LTE, private LTE using CBRS. The use cases are expanding. For instance, you go to a construction site, you want to be able to do some sort of CBRS related group call, emergency call, all with push to talk, yet that push to talk needs to expand into multiple ecosystems that may not be bringing a true walkie-talkie to the job site. And then VoLTE, is there's a big issue with, quality of service on Wi-Fi calling. There's a big issue with handoffs. There's a big issue with security. So CBRS is stepping up there. But one of the more recent developments is student broadband. And because when students started working at home and not everybody had a broadband connection, a lot of fiber companies, schools were turning to CBRS to provide that quick signal, so that you didn't have to go install stuff in an apartment complex for maybe 3 students that didn't have broadband in that apartment complex. You set up a CBRS cell, you give them a MiFi device, and it had an immediate ROI. Plus, you're able to build a foundation for a smart city. So here's the foundation: student broadband, but maybe the utilities want to come on. Maybe the police mobile data vehicles want to come on because the VPN from their traditional carrier isn't working because maybe they're rural. So all those things are playing out right now, and this is all happening. It's not futuristic, it's here and now.
I won't ask you where you got that photo from. Maybe it's your house with one of your kids, I don't know.
Ian, force him to touch on video analytics, because I'm sure it will be more interesting than what I have to say later.
Okay, well, we'll come back to it. We've got plenty of time. So Ken, I want to come back to you for a second on, let's talk about the airport. And you mentioned, of course, there's been lots of different applications deployed. I kind of like this one, but this could be a lot of different buildings this could apply to, right?
Absolutely. The reason I'm using an airport as a representative example of a pretty large geographical enterprise, at least at a given location. But this could represent others. But it's really an enterprise of enterprises as well, because it's not just the airport operator. In many cases, it's owned by the city or a port authority, things like that. But it's also the enterprises that are on the airport. It's also not just the terminal. It really, you want to be able to create a network that covers the entire airport property out to the fences and possibly even beyond the fences. So I worked with the CBRS Alliance, created this slide for them to talk about, if you're running an airport, the kind of things that you want to deal with. You've got the vehicle traffic coming in with a lot of digital signage that needs to be connected. You have the ticket kiosks, the car counters, you have traffic light controllers, LPR, the license plate recognition, street controllers, all need to be connected. Today, most of that is done via wires because just RF in the past, whether it's Wi-Fi or other meshed RF, just really didn't work. We're all familiar, or at least if we can remember way back when we were walking through terminals, you can picture kiosks and the digital signage for the flight information, but there's also retail stores and restaurants and other folks in there that need internet connectivity. You have jetway controllers, baggage conveyor equipment, etc., rental car kiosks and desks. You've got the ramp area where we've worked with a lot of customers that wanted to get network connectivity out to the airplane tugs, the baggage trucks, the refueling tankers, other service vehicles out there. And then airfield operations. I'm a pilot, so I actually get to see a lot of this in person, but there's a lot of people that are maintenance vehicles that are taking care of airport equipment, or the things that help land planes. You've got fire and rescue, air traffic controller, even we have an air traffic controller situation in my airport where there's a separate runway that they can't see, the fire department can't see, so they wanted to use a private network to just set a camera up so they could see what's going on if they got called in. And airline operations, security, etc. But all of these represent endpoints that need to be connected, and each of these endpoints typically have multiple devices attached to them. I mean, they could be laptops, they could be IoT sensors or devices, cameras, etc. And I don't see a world in that where every device is going to be CBRS enabled. So I think there is a big role for our, kind of our routers, our gateways, to be able to bridge a lot of these legacy devices and then use private LTE as the mid-haul to get that in there. But I also think the temporary locations, the wireless ones, that's where you're going to see it go first. But it is expensive to lay wires. And so if you're bringing up a facility where wires don't exist, I think private LTE is going to be very attractive to these enterprises.
Okay, great. So let's go look at a little bit further ahead here. Let's look at the next set of applications here. And Jim, I want to come back to you. So what do you look at from a Geoverse point of view? Is you've got a couple of things here, 2020, 2021. What's the next step here beyond those basic apps?
Yeah, and again, I think you're putting me in the basic category, Ian. Thanks for that. So I tried to make this as simple as possible. We're kind of this software in the middle, if you will, that right now is enabling certain types of roaming use cases. But later this year, one of the kind of home run applications for CBRS is basically any old Joe coming in off the street to a building where you don't have good service, and you're able to make a phone call, do your data session, whatever. And that the first step in that is organizing with the mobile network operators inbound roaming so that somebody from their network can roam into an enterprise CBRS network. Mm-hmm. And although you can do outbound right now, inbound is a process. And so we believe later this year, the first carrier will come on board for that, and then others will follow. And then I have a 4-letter acronym, which you say better with an English accent than I do. MOCN is a multi-operator core network. It's pretty boring, but it's pretty cool on the other side in that it allows not only current operators, but future operators to have direct access to those enterprise private CBRS networks. Remember, you're inside, you have really low power maximums, so you're probably going to be using a whole lot of spectrum inside a building. And even in environments like amusement parks, factories, you're going to have a ton of spectrum you're going to be able to use. Why not be able to share that spectrum with not only the current operators, but with all these new operators that are going to be coming to the forefront because of CBRS. And so MOCN basically connects that network to those carriers' network, and it looks like an extension of that network. So it involves radio sharing on the enterprise side and this kind of network interconnection with a trusted third party like Geoverse.
Okay. And we've actually had a question which we'll come to in the section, a little bit more detail on that as well. Okay, so Kevin, come back to you here. Next steps from the CBRS point of view from Google's perspective?
Yeah, I think when we look at the market for CBRS, we sort of divide it up into 3 categories: mobility, fixed wireless, and private LTE. Private LTE is interesting because it oftentimes has an intersection of those first 2. And so I think it's interesting to talk about some of the private LTE use cases that we're seeing that do have that intersection. So for example, on fixed wireless, we've been talking to a bunch of school districts that are wanting to provide connectivity to their students, especially in underserved areas. I mean, they're paying for that fiber connection that they're already getting to the school. So during times when students aren't there, what about delivering service to homes that are nearby? And so that would be an example of an overlap from fixed wireless to private LTE. On the mobility side, we're seeing companies work with companies like Geoverse to deploy their own enterprise network where their employees can use their handsets and but basically be on their own private network and get that communication that they can control. So the use cases are really broad, and what we're seeing in the broader market is that at this very moment, like at today point in time, the mobility and the wireless internet service providers and the major mobile network carriers, they are all going to deploy CBRS. And private LTE is newer, but it's growing fast, and it's one of the ones that I'm most excited about because we're really just seeing so many different things that you couldn't do in the past that you're now able to do. And so we're really hopeful that this brings in the next generation of wireless connectivity.
Okay, great. So Gary, I'm going to come back to you. Phase 2 of these applications here. You've got video analytics on this, but beyond the basic, what do we go to next?
So because I only went to public school, it helps me to put these things in sequence and call them phase one, phase two, and it helps me keep track of it all. So appreciate you letting me do that. So again, just one perspective on this, right, is, for a lot of companies, it will start with legacy applications. It will start with really low hanging fruit, not very exciting, not very sexy, nothing you're going to write a press release about. But from there, I think it does move to, those applications that, and the way I would characterize this sort of phase two group of applications, and they're just samples, it's not an exhaustive list by any means, but I think I would characterize it as, those things that you've read about in industry trade rags, you've seen press releases about companies implementing these things, but it's been almost the exclusive purview of larger, more resource-rich corporations and companies and factories and industrial companies. And so it hasn't really been mainstream. You haven't really seen broad-based use and deployment of some of these technologies. So I think private LTE, by changing the very fundamental economics of LTE connectivity, replacing what were metered connections with connections that I don't pay a per device recurring charge for, where I own the capital that comprises that network, and now the economics all change, right? And I can redirect some of that CapEx and OpEx into, for instance, greater density of sensors in an IoT environment, which delivers me more data. So that's an advancement, a step forward as far as IoT goes. So, what kinds of new things will private LTE enable for, a larger swath of enterprises apart from just those at the very, very upper crust? I think it's going to be, you just heard Kevin talk about fixed access. I think fixed wireless access is, we need to expand our definition of what that really means and what it can do. We tend to think of it only as a replacement for wired broadband to deliver internet connectivity where it doesn't exist today. But in fact, the definition could be much broader than that. It could be any point-to-point connection that doesn't move with anything at the other end. Could be a digital display for an enterprise. It could be out in the energy fracking fields and oil fracking fields. It may be an environment where I don't want to run Cat5 because the physical environment is challenging. So a fixed point-to wireless connection there makes a lot more sense. It costs me less money. It's easier and faster to implement. So I think we'll see a redefinition of fixed wireless access in an enterprise context. I think video analytics for sure. Jim and I agree on that. That is happening right now. Companies are doing new and really interesting things, both from the standpoint of factory floor safety, contactless payments and POS, security, retail analytics. So lots of cool stuff happening in that space. We talked about that a little bit. Certainly IIoT and Industry 4.0, again, we've read all about that. Those use cases aren't new. They're just simply not broadly deployed. Private LTE will usher in, I think, an era where companies at the small to medium size and layer of the market will be able to implement some of those same use cases. Simple IoT use cases the same way. Sensor density will be a big thing. The economics all change. And we talked about contactless POS payments. That is really germane, very relevant topic now with COVID-19 and people wanting to reopen the economy, reopen stores. So all of these, I think the storyline here is these shift from just the purview of the largest corporations to we're going to see much broader adoption because of private LTE.
Okay, great. All right, so we've got 2 slides left here. I'm going to hand back to Ken just to let's talk about 5G briefly, and we do want to leave a few minutes for questions. So from your point of view, I like this chart. Kind of shows all the different bands here fitting together for 5G. So how do you view the 5G opportunity within everything we've been talking about already, and obviously from an application point of view?
Whenever I say private LTE, kind of a year from now or 2 years from now, I'll be saying private 5G. So it's kind of, we're going to end up replacing that. The CBRS Alliance has spent a lot of time. They've released the specs that basically enable 5G to be included in the CBRS specs. We're at Cradlepoint, I mean, we work with a lot of the mobile operators. We have very close relationships with them. And so we've already announced our endpoints for 5G. You can see those on the website that are both, include all the way up to millimeter wave, which is really dense, typically focused on metro area, sub-6 for, some of the operators are doing sub-6 nationwide, et cetera. CBRS plays an interesting role because the frequency for CBRS is very, very attractive. It's sub-6, it's 3.5 gigahertz. And it's really attractive to operators because it has the, it's high enough frequency that it actually can carry some bandwidth. It has the throughput, but it's low enough that it has some punching power. It can, in many cases, cover an area of maybe half a mile to a mile, or maybe even, beyond that. And so I think we're going to see a lot of very popular use cases, a lot of the ones that I talked about before, that are going to leverage 5G. And also, from a managed service provider standpoint, there's a lot of companies that are stepping in to be able to manage these private networks. Pivot's one of them, obviously, but the mobile operators view this as an opportunity to actually operate private networks on behalf of enterprises as well. And we're going to see an auction in the next couple months. It starts in the next couple months, where enterprises can bid on priority access to a portion of this CBRS spectrum. And we think the operators are probably going to bid on some of that spectrum and operate their 5G networks in that spectrum. So anyway, the 3.5 gigahertz is really attractive to enterprises, operators, and other folks. And that's where we're starting on the private LTE here in the US, at least.
Right, great. And then, so Gary, I'm going to come back to you for the last word here, then we'll open up for questions. We've got quite a few to get through. So now you're phase 1, 2, and 3. Now you're private 5G applications, building on what Ken just said. So what sort of things can we expect?
Yeah, so, nobody's ever accused me of being too brief, Ian, but I'm going to try to be really brief here. Yeah, I'm going to say very quickly here, these are the use cases that you've heard about. They've been trialed and tested in POC environments, and some very limited actual production deployments. But these are the use cases that will really scream for the kind of bandwidth and low latency and network capacity that only 5G can deliver. So, again, smart cities, the ability for much denser sensor, density in the entire network overlaying a city. That's a big deal because the accuracy of data, it really depends on sensor density. So whether it's smart cities, smart buildings, factories, hospitals, it's all the same story as far as that goes. And again, much better economics. Autonomous vehicle is, something that's really in a very early pre-embryonic stage. I think 5G gives that the ability, because it will give it the bandwidth to connect to on a vehicle-to-vehicle basis, vehicle-to-city infrastructure basis. That is a use case that suddenly gets much, much better and much more real. A new era of medicine, I think, is coming. I think we're beginning to see glimpses of the critical need for that with what we've been through with COVID-19. And then finally, the potential for AR, VR applications across the board, whether it's in healthcare, industry 4.0 use cases, heavy industry, factory floor, all those things. I think that's going to become a lot more mainstream with 5G.
Right, great. Okay, so we do have quite a few questions. I'll leave this one up just for a second here, and I need my pictures. There we go. Okay, so we've got several here. I'm going to paraphrase here. This is a common one we've had before, actually. If an emergency interrupts consumer use of CBRS, does the consumer connectivity stop completely, or does connectivity drop to a low bandwidth limit? This could potentially limit many applications. So, Kevin, from a SaaS point of view, if the Navy comes in and lands a plane on the ship, do I lose my my security camera connection?
Yeah, great question. So with CBRS, you have 150 megahertz of spectrum, and it's only in certain areas, and they are highly populated areas on the coast, where the bottom 100 megahertz needs to be shared with the Navy. And so at this point, what's going to happen is if the Navy comes in and they're on, let's say, 10 or 20 megahertz, we'll revoke the grants of the CBSDs that are transmitting on that band. And so you will lose your grant momentarily to transmit on that band. Now, depending on the device manufacturer, you can just re-request a new grant that's on a different band of CBRS. But absolutely, it could cause a bit of a hiccup, but I think people are sort of engineering around that. In terms of it dropping to another band, we've seen, for example, utility companies take that approach, where they'll use two bands. One is a low frequency or a low band frequency where they can have constant communication that's guaranteed, and CBRS to make sure they have high amounts of bandwidth. Okay,
Ken, you've got the devices, so any issues here as things move around with different channels?
Well, I would say, one of the deployments we have with Geoverse, actually, it's a device that has one of our endpoints that has 2 modems in, and one is on using a Geoverse SIM using Private LTE, and then the other is a public SIM. And it basically enables you to do, software-defined WAN, and that could offset disruptions. Like Kevin said, some people are engineering around the possibility that it might go down temporarily. But there are applications like a security vehicle where maybe you leave the property and you do need to flip over to a public network temporarily while you're off the property. So I think we're all going through different scenarios. It really depends on the application, but there's a lot of different ways to address those issues as they come up. But again, it's really more of a coastal thing. You're not going to see that in the interior that much.
Right. So Jim, a question for you actually, and actually it's like a multi-part question which I won't go into. I'll send it to you later on. But the last part of it is, when will Geoverse or others be able to broker revenue share agreements with the operators for the private LTE network operator? So I think if you've got a private network view, you've got the big operators outside who want access in, or the private network wants access to the big operator. When will we be able to fit all that together and broker a deal?
So if you remember that last slide, I believe, that had that left part 2020, that's all going to start in 2020. Bingo. So that's part of that. And I think the driver for the operator is going to be a desirable property. So the more desirable the property, the more, they're going to be interested in that property.
Right. Okay, good. And then let's see here. We've got a couple. Let's just do. There's one I'm leaving to the end purposefully. And do you need another SIM in the mobile for CBRS? You want to take that one?
Are you asking that for me?
Yes, or anybody. Yep.
Yeah. So I mean, let's just take you call me Mr. Basic, so I'll do this basic. If you take a smartphone right now, or even one of Ken's Cradlepoint routers, we can enable a single SIM where you roam off. And Ken was talking about electronic signage, where we actually just had a single SIM in it when the CBRS network went down, or perhaps you went to an area that wasn't built. From a single SIM, we're able to select an operator based on the best signal in the area, or create a preferred operator backup. So think of it as redundancy, think of it as whatever you want. Think of like a phone where you may have public policy where a enterprise may want to give out a phone that just has that SIM in it, they control it, etc. But we're also able to work in a dual SIM environment. And a great example is an iPhone has two SIM capabilities with the iPhone 11, the iPhone SE, and probably all the new ones. We're able to enable a BYOD experience with that dual SIM right now. So SIMs are very flexible as far as what SIM options are out there, at least for us.
Okay. All right, so we're just about out of time here, but there's one question I've been leaving to the end. It's actually one of the first that came in. It's about cost. We always get it. So anybody want to talk about, is this all, obviously we're deploying networks here, but is there a price difference here for a CBRS network, or a cost difference for a CBRS network versus taking a slice of one of mobile operators, for example? Anybody want to throw any estimates out there? Is there any reference points we can point to?
I might just make real quick. The CBRS Alliance has done some fabulous work. They've hired some good consultants comparing kind of the cost of private LTE against meshed Wi-Fi, and then also private LTE versus distributed antenna systems, or DAS. And so I really would encourage people to go to the CBRS website and look at some of those cost analysis. You might, because every application is different, and it's really hard to basically say, this is the golden rule for cost, but that's a good starting point.
Okay. All right, great.
And Ian, for anybody that would want to contact me, I can put you in touch with some very good white papers that compare private LTE to Wi-Fi, private LTE to licensed macrocellular as well. So there's some good consultant work being done out there right now.
Yeah.
Okay. Good. Well, gentlemen, we're out of time. I want to thank each of you, Ken, Cradlepoint, Kevin, Google, I'll say wireless services, so I don't think you're doing search and Gmail and things, call you with all their questions. Jim from Geoverse, who is not the basic guy, he's a very advanced guy. And Gary, who went to public school, but still managed to count to 3 from Pivot. So thanks again. We are being recorded today. The recording will be available in a day or so. You'll get details as an attendee on where you can access that. If there's any questions, please feel free to contact me. I'll put you in touch with the speakers or whatever we need to do. But thanks very much, and we'll have another session in a couple of weeks. Thanks.
Excellent.
See you.